Assalamualaikum and hi. We are from group 16 and we are going to present about one type of non-destructive testing, which is magnetic particle testing. So here's our group members. So let's get started.
Magnetic particle testing is a process for detecting surface and shallow subsurface discontinuities in ferromagnetic materials. It uses magnetic field and small magnetic particles, such as ion filling, to detect flaws in components. Magnetic particle inspection can detect both production discontinuities and in-service damage. So, to understand how MPT works, we need to have the idea of magnetism. Magnetism is the ability of matter to attract other matter to itself. Objects that possess the property of magnetism are said to be magnetic or magnetized, and magnetic line of force can be found in and around the object. A magnetic pole is a point where a magnetic line of force exits or enter a materials. We need to know that magnetic field lines form complete loops. They do not cross each other, follow the path of least resistance, all have the same strength, have a direction such that they cause poles to attract or repel. So, after we know all that, we can know how the MPT work. How does MPT work? A ferromagnetic test specimen is magnetized with a strong magnetic field created by a magnet or special equipment. As you can see in the first figure, if the specimen has a crack or discontinuity, it will interrupt the magnetic field flowing through the specimen and a leakage field will occur. Finally, male ion particles coated with a dye pigment are applied to the specimen. As you can see in the second figure, these particles are attracted to leakage field and will cluster to form an indication directly over the discontinuity. This indication can be visually detected under proper lighting condition.
Hello everyone, my name is Muhammad Usiri. So today I'm going to present basic procedure and important considerations for magnetic particle inspection. So actually they consist of component pre-cleaning, introduction to magnetic field, applications of magnetic media, and last one, interpretation of magnetic media indications. The one that I will present is component pre-cleaning and introduction to magnetic field. So next slide. So the first one we have component pre-cleaning. Actually, it is important to note that the component must be cleaned and dry before starting the inspection. For instance, oil or grease presence actually disturb the process and prevent the attraction of magnetic particle to leakage field. Hence, contaminants also interfere with interpretation of indications. So the next one we have introduction to magnetic field. Why? Because it is an important considerations for magnetic particle inspection. Hence, magnetic field can be introduced through different ways. The first one being by flowing an electric current through a specimen. This is called a type of direct magnetization. And then we can introduce magnetic field by using permanent magnet or electromagnet, which can be considered as an indirect magnetization. And the last one, we can introduce magnetic field by using a coil, which the same as the second one, an indirect magnetization. Thank you.
And then we proceed with the application of magnetic media. MPI can be performed using either dry particles or wet particles. Okay, first with the dry method, the particles are lightly dusted on the surface. And then the dry method is more portable. Magnetic particles come in a variety of colors, and a color that produce a high level of contrast against the background should be used. And then we proceed with the wet method. The particle is flooded with a solution carrying the particles. The wet method is generally more sensitive, since the liquid carrier give the magnetic particles additional mobility. And wet particles typically supplied as visible or fluorescent visible particles viewed under normal white light, and fluorescent particles are viewed under black light. And then we proceed with the interpretation of indications. Okay, firstly, after applying the magnetic field, indications that form must interpreted. And then second, this process requires that the inspector to distinguish between relevant and non-relevant indications. The following is example relevant indication process. We have example of a process that show fluorescence color by using wet particle method, which is crane hook, gear, drive shaft, spline shaft, and large bolt. The example of image for this method is gear with service-induced crack. And then it will show visible color by using dry powder method. Below is the example for this method, which is lack of fusion, 2 crack, and short and 2 cracks. And the example images for this method is 2 crack in weld. And then we proceed with the demagnetization. Okay, parts inspected by the magnetic particles method may sometimes have an objectionable residual magnetic field that may interfere with subsequent manufacturing operations or service of the components. Okay, possible reasons for demagnetization include may interfere with welding and or machining operations, and then can affect gauges that are sensitive to magnetic fields if placed in close proximity. And then abrasive particles may adhere to components surface and cause an increase in wear to engines components, gears, bearings, and example. And demagnetization requires that the residual magnetic field is reversed and reduced by the inspector. And this process will scramble the magnetic domains and reduce the strength of the residual field to an acceptable level.
Now, we continue with the advantages of magnetic particle testing. Magnetic particle testing, known as a fast method of inspection and indication, are visible directly on the surface of the part and constitute a visual representation of the flow. Besides, this testing also considered as a low cost compared to the other non-destructive method because the material and associated equipment are relatively inexpensive. Next, it is easy to detect both surface and near subsurface defects. Magnetic particle testing is a very portable inspection method, especially when used with battery power equipment. In addition, this testing can use to inspect parts with irregular shapes easily. Pre-cleaning of components is not as critical as it is for some other inspection methods. Lastly, we move to the disadvantages of magnetic particle testing. One of the disadvantages of magnetic particle testing is the inspection of large parts may require use of equipment with special power requirements. Apart from this, the testing itself is limited subsurface discontinuity detection capabilities. Magnetic particle testing cannot inspect non-ferrous materials such as aluminium, magnesium, or most stainless steel. Some parts may need removal, coating, or planting to achieve desired inspection sensitivity. Moreover, this testing just only applicable to the ferromagnetic material. Lastly, for post-cleaning and post-demagnetization is often necessary. Here are all the references that have been used in this assignment. So, that's all from us. Thank you.